Hello dear mathematicians, today we're going to look at a technique called packing which might help you with algebraic expansions. This is something quite unique, and so let's jump right in. So here's a common mathematical expression which, if you were to expand normally, you would just multiply the bracket through by distributing here. So what we need to do here is to do 3x times x, which is 3x squared, and 3x times negative 2, which is minus 6x, and 5x times x, which is 5x squared, and 5x times 1, which is 5x, and adding the bits which are similar together, so we'll put the x squares with the x squares and the x's with the x's. We realize that we have 3x squared plus 5x squared, which is 8x squared, and the x's with the x's will give us negative 6x plus 5x, which is negative x. Now there's absolutely nothing wrong with doing this. It's the traditional way to do things. It's completely correct. It might not be the fastest way because it doesn't get you to the answer immediately. And so let's explore what the packing technique might look like instead. Realize here that 3x times x is going to generate x squares for you, and 5x times x is also going to generate x squares for you. However, 3x times negative 2 is going to generate x's, and 5x times 1 is going to generate x's. So as we notice that, we can simply count the number of x squares and count the number of x's. So how many x squares do we have? Well, let's think about this. I'll have 3x squares and 5x squares, which will give me 8x squares. How many x's do we have? Well, we'll have negative 6 plus 5, which is negative x. And so without expanding the brackets, we can actually come to a solution immediately. And now for a slightly harder expression, so we could try both techniques and see what the difference might be. And so with my traditional expansion here, I'll have 3x times 4x squared, which is 12x to the power 3. 3x times negative 2x, so positive times negative is a negative, so minus 6x squared. 5x times 2x squared, so 5 times 2 is 10. X times x squared is x cubed. 5x times 1, which is going to give me 5x. Negative 4x times 2x, which is negative 8x squared. Negative 4x times positive 5, which is negative 20x's. Ordering everything in order of powers from the highest to the lowest, 12x cubed plus 10x cubed is going to give me 22x cubed. Negative 6x squared minus 8x squared is negative 14x squared. And then for our x's, we'll have positive 5x minus 20x, which is negative 15x. Again, there's nothing wrong with that. This is absolutely fine. And so this is very good. Now let's try and explore this using a packing technique instead. So if I was to just do this question, I wouldn't need to underline every coefficient, but for the purpose of the video, I think it's quite useful to see how the coefficients are generated. Now we notice just by looking at this that we're going to have some x cubes, we're going to have some x squares, and we're going to have some x's. So which coefficients are going to generate the highest power of x, which is x cubed first? Well, 3x times 4x squared and 5x times 2x squared. Well, we'll have 12 here and 10 here, so you could say this is 22x cubed. And looking now for the coefficients of x squared, I can see that 3x times negative 2x is going to give me minus 6x squared, and I'll have another bit over here with minus 4x times 2x, which is negative 8x squared. So we'll have minus 6 minus 8, which is minus 14x squared. And for the section which generates x's, well, the first bracket doesn't generate any x's. We'll have 5x's here and probably another negative 20 over here. So what is 5 minus 20? Well, that'll be minus 15 x's. And as you can see, this result is the same as the previous one and is as valid and as good as the previous technique. Now you could do this without even having to point out or underline any of the coefficients. You could simply see that that's where they are. But to start with, I would recommend that you just underline them just so you can spot them. So the idea behind this technique is simply to recognize the coefficients generated by each multiplication. So let's see how we could use a packing technique, approaching a totally new question without expanding the brackets, without underlining anything, and just seeing how that could be useful. So in this question, I noticed that 3x times x squared is going to generate the highest coefficient of x, which is x cubed. So I can say here that I have 3x cubed. And then I'll look at how many x squares I'm generating, and I only see a 5 times 2x squared to generate x squared, so I'm going to say, okay, well that's 10x squared. And then looking at the coefficients of x, I see 3x times negative 2, which is going to be negative 6x's, and then there's minus 4x's hanging out at the end over here, so I can say that's minus 6 minus 4, which is minus 10x's. And for the constant term, I can see that there's only a 5 times 1, which is going to give me a 5, and that is how I would expand this bracket. Now you notice we're just missing an intermediary step. The work is completely accurate, completely fine. There's no problem with it at all. It's just a way to shortcut algebra. So I hope this little Mathematrick was useful to you. Remember, mathematics comes easy with the Mathemagic channel, and like and subscribe so you can see more tricks and also follow along papers as well as short lessons. Thank you so much, and we'll see you on the next one.